So today's it's actually kind of all right that we started a little late. I don't think I have a full 50 minutes that I really need to talk to you about today. But we want to introduce databases. This is something that a lot of you may have already seen before. You may have already come across databases at least some level through your coding. And today I just want to give an overview of what databases are, how we're using them, and what these things are doing for us at a very high level. I'm not going to get into too much detail about databases. We do have several courses in databases. If you want to know more, if you want to dive into the details, we have you covered there. We have plenty of content in those courses. I just need to get us on our feet enough that we can plug in a database into our web apps so we can use databases for our purposes of building apps with more functionality than we have now. So databases are going to give us a way to store data on disk. Now this is something, of course, we can do already. We can save. We've been doing file I/O throughout this semester, throughout 115, 116. You've done file I/O before, saving data to disk. We've saved binary data to disk using with image I/O, image uploads. We would read the bytes and then save those bytes directly to disk, uh, without uh, without having to work with textual formats. We could also save text files. You've probably worked with CSV, depending on which semester you've took 115. I think we've been doing CSV for long enough that all of you've at least parsed CSV files in 115. So we've done file I/O before. So why do we need a database when we can do that? Well, the database is going to give us a lot of optimizations for that. It's going to keep us away from the low level details. When we have to store CSV data, for example, save an entire image. That's not too hard. We can handle that. We can work our way around that. But once we have more complex data, once we have all the data for user accounts in our web app, now things get a little more complicated. It's a little trickier. We have a lot of questions of, okay, how do we store that data? How do we represent it? How do we save that in some file? And what if we have maybe a mix of textual data and binary data, like we had when we had post request containing an image? Like how do we handle those? Do we really want to think about those low level details? And at least for our purposes in this class, the answer is no. If you want to think about those low level details, again, we do have database courses that will crack open a database. We have a course, I'm forgetting which is which, to be honest, but one of the courses will do something similar to what we're doing here, is actually implement large pieces of a database software from scratch without, I don't think it's necessarily from scratch, but actually getting into those low level details and getting and implementing the API for a database of how to actually store this information and do it in an efficient way and actually build those optimizations. So if you are interested in that, we got you covered there. I'm not going to touch it on in this course. We're just going to use databases as a black box in this course, similar to how we're using TCP. So a database is going to be a server that's running for 460 and 462. I think, looking at the numbers, I think 460 is the one that goes into the low level details, and 462, I believe, is the one that uses SQL and databases and builds out the architecture for an app, talking about multiple tables and joins and how to get all that, get more complex data implemented. I believe 460 is, okay, if somebody sends us a SQL query wanting to insert data into a table, how do we actually do that and how do we save that to disk? I believe is the cutoff. I might have those backwards, but I believe that's that's what those two courses are. That is what those two courses are. I think that's what I believe that's the distinction between them. 460 is a prereq for 462 because one of those, I believe 460 is a new course, at least since I've been faculty here and not a student. So I only took 462. 460 didn't exist, so I think 460 is that new one. But since 460 came on, they may have split it. I just haven't kept up on the exact details. But at some degree, it's one's low level details. That would make sense for 460 to be the low level details and have that be the prereq for the one that covers the high level details. That would make sense. I guess it would make sense the other way around. Anyway, so a database, specifically a database server, is what we want to use. We're going to install this software, run it as a server, and it's going to listen for connections over TCP. And I have this in a few slides, but I should mention it now. We're not going to work with databases at the TCP level. We're not going to be making those TCP connections and reading bytes off a socket and writing bytes to a socket like we're doing with HTTP. In fact, we don't even have a homework assignment that's going to use databases. This is all information. This week is all information for your project. There's no homework assignment for databases. This is all project stuff, so libraries are on the table. In the documentation for that library, you can say, we're using this to connect to the database, and somewhere in there show the TCP connection would suffice for those. You're not going to have to actually, you're not actually going to have to connect to that TCP socket manually at all. What we are going to do is connect to its API. It's going to provide an API that's going to let us send queries to it to be able to store and retrieve data. And that API is going to implement all the implementation that does that low-level file I/O, that saving to disk. How are we going to represent it? This data on the disk, and how are we going to retrieve it efficiently? So we don't have to think about all those low-level details, at least in this class. So we get to actually think about how are we going to structure our app, how are we going to move data around. We don't have to think about these low-level, how are we going to represent this data on disk kind of details. We don't want to be thinking at that level when we're designing a web app. So we'll take a look at two different servers, MySQL and MongoDB. These are two different approaches to solve the same problem. We want to store our data on disk. That's our problem that we want to solve. And these are two different pieces of software that are going to solve that same problem in different ways. And we'll talk about those different ways. They're both going to listen over TCP. MySQL implements the common query language SQL. The structured query language. And MySQL is one of probably the most popular server that implements SQL. There are a lot of different SQL servers. Postgres comes to mind as well. It's a very popular one. But MySQL is one of the servers that implements SQL. So the SQL, this query language, is defined. It's out there, and then there are multiple servers that implement it. MySQL being one of them. Alternatively, we'll also look at MongoDB. There's another very popular database server that's out there. It doesn't use SQL. It uses its own query language. Its query language is going to be based on document stores. So instead of having what we'll see as a table structure in SQL, we're going to have just storing documents, which are going to be very similar to JSON in structure. So MySQL, in both of these, this is true for both of these. Oh, I meant to mention that in this slide. This is software that you'll download. These are going to run as separate apps on your machine. You'll download the software, install it, run it on your machine. And once it's running, it's going to run in the background, and it's going to be listening for those TCP connections. So the first thing we have to do to use a database is download it, install it, run it, have it running on the background, and then in our code, we're going to connect to the TCP socket for that database. We're going to send it, connect to it, create a TCP socket connection, and then start sending it queries through that TCP connection by using the API provided. So at some point, we're going to have to make a network connection, just like our clients are connecting to our web app, same technology, same TCP, but we're going to typically be running it on localhost and then connecting to that locally running database. These servers are meant to be full servers like this. Just instead of implementing HTTP, they implement SQL or Mongo. But they are servers, and they're made to run over a network. So if you want to have your database running on a separate machine, you want to have a distributed system, you want to separate your database from your app, which is common once you have large apps and lots of data. You usually want your database running on a separate machine because you need a machine with a large hard drive to be able to run your database. It's all set up to do that. So even if you're running your database and your app both on localhost, you're still connecting to the database via network technologies, specifically TCP. So you still have to make that network connection, even if it is running locally. One technology to get around that, I don't know if technology is the right word, but if you've used SQLite before, that's a kind of a simulation of a SQL server that doesn't actually have to run a server. So if you used that before, you're using that specifically to cut out the TCP connection and make the database setup a little bit easier. So if you've used that before, you were cutting out some steps, mostly used for like prototyping or just building small apps. If you're in a hackathon, SQLite's probably your best option. But we're only going to be talking about the fully fledged database servers here, MySQL and MongoDB. So when we do it, download, install, and run MySQL, by default, it's going to run on port 3306. So it's going to listen for TCP socket connections on port 3306. We're going to do that TCP handshake and make a connection on port 3306. And then we have a connection to our MySQL database server. So we can start sending it queries and start communicating with this other piece of software that's running on our machine. You can start to see where apps can start to be distributed. We have two different processes running on our machine, communicating through TCP. Those could easily be on different machines, and start to get an idea of a distributed app. What is a distributed app? We can start moving these pieces to different machines and use these network technologies. So once you have MySQL up and running and listening on port 3306, or if you for some reason want to specify a different port, you could have it running on a different port. But once you have it running, I'm going to assume the default port. Once you have it running on 3306, you're going to go to your language of choice, your libraries of choice, your framework of choice. Again, this is only for the project. You can technically use a database for the next homework for authentication. We will have to store data, but if you want to do that with just a file, I'd be fine with that because I want to talk about the authentication process, not really the data storing process. For your apps, though, for your project, you'll be using libraries are on the table for that. So you'll run one of these servers and then connect to it using whatever library you have for that language, including whatever libraries included in your web framework if it contains a way to connect to these databases. A lot of web frameworks out there, they're going to have something in their configuration, which is going to say, just tell me what database you're running and any username password I need to authenticate. And then your web app will have those libraries, have that API implemented to be able to communicate with that database. So whatever the situation is for your language, for your libraries, for your frameworks, for whatever software stack you're using, you'll have some way to connect to this server using an API of some level. So for this, you have to tell that library, whatever it ends up looking like for your case, you have to tell it how to connect to your database. So where is this running? Most of the time, if you're using the default port for a server, you can just say, hey, I have a MySQL server running on localhost. Go connect to it, and then the library will take it from there. It'll assume 3306, for example. And all this is true for MongoDB as well. We're not going to get down to the TCP level stuff. We're going to use the libraries for this. There's no need to get into the low-level details of databases. We just need this piece for our architecture so we can start storing data and start getting the full force of our web apps. This is one of the last pieces that we need to really start talking about fully fledged web apps. And even Friday, we'll start talking about the structure, seeing how all these pieces come together. We talked about a lot of disjoint. I'll take a second to talk about this right now. We talked about a lot of disjoint pieces so far in this course. We threw WebSockets and AJAX and now databases out there. A lot of little pieces. And Friday is probably the first lecture where it's all going to start coming together. And we're going to see, okay, how does one app use all of these pieces to get a job done, to get a full user experience out there, an app that somebody can use. We'll start getting into those good bits pretty soon. Then next week we'll talk about authentication, which is another not necessarily a fundamental piece, but one way that a lot of these technologies come together to be able to create user accounts. With user accounts, we need a database, we need encryption, we need hashing, which we haven't talked about yet. We need a lot of these technology. We need cookies. We need a lot of those technologies to come together to be able to have authentication in our app. So we're going to see how a lot of pieces come together to build that piece, the authentication piece. And then at that point, we have web apps. We have all the features you would expect from an app once we have that topped off. And then streaming, that's kind of like a bonus topic. Like let's stream some stuff now. But we'll have all those features that we need, and then we can start talking about full web apps. And I'll be soliciting ideas. Maybe we can start during the Q&A today. I'll be soliciting ideas for what kind of web app you'd want to see that we can build and talk about in class. Yeah, and then all right, and then that API you're going to use to actually talk to the database. So once we have MySQL running, here's some. This happens to be Scala code, but I just want to give this as an example of what it'll look like in some code in some language. These are the pieces that you're going to need to tell your code to tell your API. So once MySQL is running and you have that library installed, you downloaded that library, linked it to your project using pip or npm or Maven, whatever you're using to manage your dependencies. Once you have that library in, you're ready to connect to that database and start sending it queries. So the first thing we need is to connect with MySQL. When you install MySQL and you start running it, you're going to go through the configuration script that they have. One of the things that you're going to do in that script is specify a username and password for your database. So when we go to connect to this, we're going to have to tell it what URL the server is running at. For our purposes, localhost is the keyword here. We're running localhost. I'm using a JDBC library because this is Scala code and I'm using a Java library. The Java database connect library using the MySQL API. So this is the protocol we're going to use, JDBC MySQL. We're going to send MySQL queries to this URL, localhost, and the default path on localhost is MySQL. And this will assume, the library is going to assume port 3306 on this. So the URL, this is the default URL that I'm going to have with the default, with the JDBC protocol. And then I have to specify that username and password that I set up when I set up the database. I just happen to choose a very weak password here, 123456778, and I use the default username of root for my username of the database. Now, once this server gets a connection and says, "Here's my username and password," the username and password checkout. Now it's going to authenticate, and then accept queries, SQL queries on this connection. And I, of course, have to call connect with those values. This is a very there's a very important security risk here. So what I'm doing on this slide and the previous slide is something you must never actually do in production. This is a very bad thing. What I have right here is a password hard-coded in my code. This is a very big security concern. We need to be aware of this and think about what this means, especially when you get out there on the job, you're working on a team, and you have an app that is controlling sensitive information from your users. This is a very bad thing. You can't have your database password, or really any password, hard-coded in your code, because then anybody with access to that code, of course, has access to the password. And this isn't not a feature that we want. We don't want everybody with access to the code to have access to that password. So there's one really bad thing. Of course, if you're checking into a public repo, your app's compromised at that point. All the data is compromised at that point. Isn't it risky to store them in plain text? We actually do have to store these passwords in plain text, unfortunately. So anybody who can access the server where that's stored, wherever that's stored, is going to get the plain text password. This isn't something we do with user accounts, because the user is going to provide their plain text password every time they log in. But we don't have a dev sitting on the production server manually typing in the plain text password every time we need to connect to the database. So we do have to store this programmatically some way. We do have to have it stored in plain text, unfortunately. It's just a feature of being able to authenticate programmatically. We need our software to send a password to the database, and that password has to be plain text. Inside MySQL itself, hopefully they're doing what they should be doing in hashing our stored password. But the password that we provide to authenticate, unfortunately, has to be plain text, just the way the technologies work. And next week you'll be able to see why that is the case, why we need that plain text password. So we don't want to store it in our code, though. We don't want to hard code it here, because then everybody on the team, even that new intern you just brought on, has access to that password. If somebody can get an internship at Google and all of a sudden have access to all of their data, it just doesn't work like that. You're not gonna trust everybody on the team, every developer on the team, even with that password. So we want some way to be able to get around this. In the specific danger. So right now we're working on localhost. We're just connecting to localhost. But this machine is going to have an IP address, presumably, especially if it's a web app. This machine is not necessarily, but probably connected to the internet. I say not necessarily because we can have the database running on a machine that's not connected to the internet, and then only have that connected to our web app machine, which is connected to the internet, and then there's just a connection between those two machines. Might be the only connection. There are ways that we can set up the architecture to get around this, but by default, you are connected. If you are connected to the internet, somebody can replace localhost with your IP address and connect to your database if they have your username and password. This is a very big concern, that once you have a networked database, which they're all networked except with exceptions like SQLite, you have this network database server that speaks network technologies, that speaks TCP. That means anybody with the IP address, username, and password of that machine, of that server, can access all of that data. So if that password's compromised, that password and username are compromised, and somebody has that IP address, we're done for. There's no privacy anymore. All of our user information is out there. It's all leaked. It's all gone. So what one approach that we can take is, instead of storing this in the code, have this code look up an environment variable. Use whatever library you have in that language to look up an environment variable, which is a variable that's stored at the operating system level. That you can go into the command line, you can set those variables, you can read those variables, but you can also read them from code using built-in libraries. I would imagine every language has, I haven't come across one that doesn't, but every language has some built-in way to be able to read environment variables from the operating system. So here you would just read that environment variable, storing that password, and then on the production machine, you would set, when you go to deploy the app, you or someone on the DevOps team is going to set that password, set that environment variable in the password, and then only people with access to the production server are going to have access to that password. So you're limiting the number of people who can access that database. And don't ever use default passwords on anything that you expect any amount of security on. Don't use default passwords. This is, if you've heard of the Equifax leak, where hundreds of millions of people's financial information was leaked, their credit records. That leak was, at least in part, due to them using default passwords. It wasn't with MySQL specifically, but it's but they were using software out of the box and just not replacing the default passwords. So somebody just tried to connect to that server, assuming that they used the default password, and they were authenticated. And they said, "Hey, this is a problem," and it snowballed from there. But a very bad, very sloppy thing to do. And there are actually, so you might think, well, nobody's going to attack my server. Somebody actually has to try that first. And who's going to be sitting there trying every IP address on the internet, trying to look for these vulnerabilities? Well, no, they don't, but they write bots that do. There are bots that will scan just random IP addresses, just continuously scanning the internet, looking for known vulnerabilities. So if you're using a default password, if you're using an outdated version of a software with a known vulnerability, don't think that you're safe just because your app is tiny and nobody's going to attack you. They're constantly scanning and looking for these vulnerabilities. Somebody's going to find you. They're going to get a notification. It's going to say, "Hey, your bot, just the bot that you wrote. Hey, I just found something." And then they're going to start attacking after that, or have another bot that attacks. They might even have the full process automated to try to extract information. But they are looking. On the apps I deploy, I look at the server logs, and yeah, bots are constantly attacking my servers. We have to be protected against this stuff. When we use Docker, so for your projects, we'll use Docker to set the environment variables. We actually did this with the the home directory, I believe. We set the home directory environment variable with the I think it's just env to set an environment variable. We can do this right in the Docker setup. We can have our Docker file or our Docker compose that we'll see on Wednesday. We can, in those files, set these environment variables, and then our code can read those variables. So even when we have this automated production and environment set up through Docker, we can still set those environment variables without having to set up Docker, run our nice script, which just says Docker build everything. After that, we don't have to have somebody enter into that Docker container and set an environment variable. That would defeat a little bit of the purpose of having Docker have a nice smooth setup. So what we can do is have our Docker file set up, check it into the repo with just a placeholder. Just say, this is where my password is going to go. And then when you clone that repo onto the production server, go into that Docker file, replace that with whatever password the DevOps team chooses for that app, and then set it up. So Docker kind of puts us back to a hard-coded password, but there are ways we can get around that without hard-coding it into our code like that. It would still be hard-coded into the Docker file, but we'll do what we can. Just generally having a sense of the vulnerabilities, a sense of the risks here, and making sure you're absolutely limiting who can read that password. These passwords should always be on a need-to-know basis. If somebody doesn't need access to that password to do their job, they should be denied access. You don't just hand it out to everybody. So just general DevOps things of making sure that your database is staying secure, and being mindful of that is important. And you can also, I would say, additionally, do all these things and also change your DB settings to not allow outside connections. If you're not running a distributed app, you can restrict it to not allow networked connections, only allow connections on localhost. And if you are running a distributed app, you can whitelist certain IP addresses. You can whitelist the IP for your app, or IPs if the app itself is distributed as well, and block all of those outside connections. So even somebody with your password still can't get into your database, adding another layer of security. In your databases, they have this built in. MongoDB does this by default. You have to explicitly allow outside connections for MongoDB. MySQL, you have to, I believe, I'm quite sure, 90% sure, that you have to turn this setting off. That's part of why MongoDB asks you to set up a username and password when you first set it up, because they're going to allow those outside connections by default. And if you don't have a password, username and password, well, MongoDB doesn't ask you to set up a username and password because it's going to have those blocked by default, at least in part why they do that. So once we're all set up, we can start sending SQL statements. We can start sending SQL statements to our database. So we're connected. We used our library, sent that URL, username, password, made that connection. We're connected via TCP. Now, whatever the syntax is for our specific library, we can start using that to send these queries. So with this specific language, we have to create a statement and then execute some text to be able to run a statement. And here we're not going to talk about SQL syntax in depth. I provided some links. There's, as usual, W3 Schools has us covered on this one. MongoDB, there was, I think, a tutorial that has us covered on that front. So I won't go over the syntax, just very lightly here. I'm going to create a new table. So SQL, I do want to talk about the structure. SQL works on tables, and those tables have rows. This is very much like a giant, well, I guess it doesn't have to be giant, but very much like the structure of a CSV file. So I'm going to create a table, which is kind of like create a new CSV file. If it doesn't exist, so if this table already exists, don't do anything. If I don't have this and the table already exists, my program's going to crash. I don't want that. So if this table doesn't exist, so if this is the first time I'm starting up the server, create this table. If it's not the first time I'm starting up the server, if I just rebooted the server, don't do anything. But create a table named players with two fields, username and points. Username is going to be text and points is going to be an integer value. And this is something that we already have more features than we have with CSV. CSV can only store text values. Those text values might be in the integer format, but we have to pull the text out and then convert them to ints and hope that they're in the right format, that nobody violated. Nobody had FOR for 4, because CSV, there's nothing, CSV isn't anything. It's just a file. It's just a standard that we're following. If we try to write FOR instead of the numeric 4, nothing's going to stop somebody from doing that. But with MySQL, we have some protection. We can say points, it's got to be an int. If somebody tries to give you something that's not a well-formed int, don't do it. And when I pull this data out, convert it to an int, do whatever you need to do to store this as an int and give it to me back as an int instead of using text for absolutely everything like CSV. So we already see some better functionality there. These tables are going to be the base structure, the base way to organize our information. We're going to create tables which have columns or attributes or fields that I called them the first time, values for each entry, so to say. And that's our big structural point for SQL is these tables. And if you're inserting information into the database, always use prepared statements. This is something we'll look for in the project part, phase 2. It is one of the security things, sanitizing your HTML and escaping your HTML and sanitizing, or rather preparing your SQL statements. These are the two biggest things that we're going to look for in terms of security. And what that means is when we insert values into a table, we're going to use this insert into table name. These values, always use these question marks, this question mark syntax, which any example you look at better be using this way of inserting into a database. These question marks are placeholders for two values that we're going to insert. First question mark being the username, the second question mark being points in this case. And then we're going to replace those question marks with the specific values that we want to enter. We're going to replace those. Each language is going to have slightly different ways of doing this. Most languages will have the prepared statement, and then as a second argument, a list of all the values that you want to add. This specific library I'm using doesn't support that syntax. You have to set them one at a time, specifically because I'm in a strongly typed language and I have a string and an int that I need to add. So I can't just give it a list, not easily anyway. And then finally execute the statement. Never, don't forget to execute them once you set them up. It's one of the bugs we've all probably been through at one time or another. You might go through it on your project. Is why is my data not making it to the database? I swear I'm doing everything right. Well, it's because you didn't call execute. I know I've done it. It's frustrating. It's always embarrassing when I finally find it. Like, I never called execute. So if you don't prepare your statements, what happens if you don't prepare your statements? You don't use those question marks? Well, now you're vulnerable to what's called SQL injection attacks. So say, for example, instead of having these question marks, we use pure string concatenation, insert into player's value, parenthesis, close string, plus whatever value the user gave me, plus quote, comma, space, quote, plus whatever other value the user gave me, plus quote, close paren, quote, close paren. What if we did just raw string concatenation instead of this, which would be valid SQL syntax, to be able to just replace these question marks with the actual values we're looking for. But what's the danger in that? Why do we want to prepare these statements? Because then we're vulnerable to what's called SQL injection attacks. So if we're using that concatenation, what's stopping somebody from, instead of entering a player name in the previous example, instead of actually using that player name, they're going to have input something like this as their name in the name field of the form of the website where they're connecting to, or however it's set up. They're going to end whatever statement I'm trying to run, or the developer or you are trying to run. End that statement. They don't care what it is. They're just going to end it. And then add their own SQL statement. In this case, delete the whole table containing all the players. At this point, since you're using string concatenation, they can execute any SQL statement that they can write. They can destroy a database destroy a table like this, or they could do something even more malicious. They might say select star, which is going to retrieve all the information from a table, and retrieve all that information, maybe of the user accounts. Maybe they steal a bunch of usernames and hash passwords. Maybe they steal credit card numbers. Or maybe they can insert into the user table or make an update. Maybe they can change their user account to be a mod account. Maybe they can change their account to be an admin account and then start accessing other things that they're not supposed to. There's just a lot of stuff that they can do once they're in your database. This is still the most common successful attack out there. Any SQL vulnerabilities, not always necessarily injection attacks. I like to think that pretty much every developer out there is preparing their statements. They're all preparing their statements at this time. But SQL attacks of this sort, some way to get their SQL commands executed on the server, still the most common successful attack. That when you read in the papers, well, we don't really read papers these days, but when you see the headlines, big data breach at some company, PSN loses all kinds of credit cards and stuff, that it's most likely a SQL attack. It was an attack on the database that caused that. So you could check for illegal characters. The problem is, or ban semicolon, you can do things like this. The problem is that SQL is quite a bit more complicated than HTML. Like HTML, we just banned 3 different characters. But with SQL, the language itself is more complex. It is a full language. It is Turing complete. There's just a lot you can do with SQL. So limiting the attacks gets a bit more complicated. So maybe they don't write their whole own statement like this. Maybe they can just hijack our statement. Even if we just have insert into this, they can still insert some malicious data. There's just things that they can still do just by hacking into this statement, making it the common approach to just prepare the statements instead of looking for all those characters. So why does the prepare statement, doesn't the provided user input get plugged into the... So with the prepared state, you're right. Thank you for that question, Coffee and Burgers. I didn't explain this really well. With the prepared statement, anything that we put into those question marks is going to be treated as a raw value. It's only going to be interpreted as some bytes representing a value, and that's what's going to be inserted into the database into the table in this case. It will not be interpreted as SQL code. So it's possible that on some low-level details, it is in the prepared statement, it might be saying, okay, if there's a semicolon, and going through a lot of process like that to clean things. But I believe it's actually just treating this as raw UTF-8 encoded bytes and just inserting that into the table, into this new row. It's just treating it strictly as a value, not as part of the SQL statement itself. And that's what we get from the prepared statements. So preparing your statements, if you're using SQL, I expect to see this in your project phase 2 code. Very, very important. If you're not preparing your statements, if you have string concatenation here, then you kind of put me in a tough decision, because then I have to decide what the punishment is. It should be a 0 on that entire phase for a security risk. Any security risks, like, it doesn't matter how nice your app is. If you're out there in production, you're working for a company, you build this beautiful app for them that has all these features and is really great, but it has a security vulnerability, like, you just did more damage than you helped that company. And you're probably going to lose your job. You should lose your job. So at the very least, you can get a 0 on a course to drive that point home. Like, you need to care about this. You can't just think about when it's your data that a company is storing. You want them to take all the precautions necessary to protect your data. You have that same responsibility when you're a developer. You need to protect your users' data. You don't want to compromise their privacy, their security. You don't want their information leaked out there. It's very, very important. One of the security in general, it's one of the topics when I get a chance over the summer to revise the course and take a look at it again. Security is one of the topics that I want to highlight way more than I do at the moment. We don't talk about it too much. Naturally, next week we'll talk about it a decent amount more than we have before. But it's one of the topics I want to put into the specifically in the grading structure more. I think a security vulnerability should probably be treated like an AI violation. It should just be F in the course. I don't know if I want to go that far, but it's things to consider. Security is the most important aspect. If you have a crappy app that's secure, that's way better than having a beautiful app that's insecure. Can we store usernames and passwords in our code? Didn't I just talk about that for like several slides? No. And if that's part of your instructions, so when you submit your phase 2, part of your instructions, some documentation in the possibly in the README, it should say, here in our Docker file is where the password goes. Choose whatever password you want and replace that password. You should have something like that in your instructions of how to run the software. So when we go to grade those, we'll actually go in there and replace those with whatever passwords Nick and I choose. You shouldn't have those. Like, that's an actual security risk. If you have a hard-coded password and it's stored in a public repo, and I start up that server, like, now I have a vulnerability on my server. All right, so yeah, these slides, I end up talking so much on each slide. I actually thought I wouldn't fill up 50 minutes, but hey, we are getting there actually. So once we have the connection, we have data in there. We saw on the previous slide just one example of how we can create a table and insert data into it. Now, getting data out of it, the very simplest way is to use a select star from that table. That's going to give us all of the information in that table. In this case, we're going to get it in some result set object. Details will be different for each language, so I won't get hung up on the details, but you're going to get get the results in some object that you can iterate over to be able to get all of the information that you want out of that. Since we're using this star is treated like a wildcard, just like it is in many other languages. This says get all of the information from this table, If you only wanted some information, you would replace the star with whatever information you want. Select username from players would just give you the username. Select points from players would just give you the points. I did select star, so I'm going to extract whatever values I need as I'm iterating through this data. I'm going to get those username and points. And then here I'm just adding them into some key value pair data structure to do whatever I want to do with it after that. After that, it'd be whatever your app is built to do. Whatever it's run to do, that's what you're going to do with that data. You can also filter. SQL is a pretty powerful language, like I mentioned earlier. You can filter, select star from players where username equals Mario is only going to give you Mario's record, and lots of different functionality you have in the language. Again, I'm deferring to the documentation for the actual SQL commands and the SQL setup. So, as we're seeing, SQL is set up much like the structure of CSV. And with CSV, we couldn't really store data structures, so to say. Like, what if we have CSV and one of the columns of our CSV, we want to be an array? How do we do that? How do we store an array of values as a value itself in a CSV format? There are ways we could do it with escaping commas and things like that, but it gets tricky, to say the least. In SQL, the answer is to use joins. You would store that array in a separate table, or all those arrays in a separate table, and then do a join where certain keys, certain unique identifiers match. You would join that data together using the keyword join in SQL and get that information, stitch that information together as you write your queries. That's the SQL way to do it. Or we can use something called MongoDB. We can use our other database that we're talking about. And I only have a few slides, so I did start late, so I do want to get through these. I can get through these slides today. With MongoDB, instead of storing table and row format like a CSV style, we're going to store documents. Document based, meaning with documents being in a JSON style format, documents are going to be like JSON objects, and we're going to store documents in our database in collections instead of tables, port 27017 instead of 3606, and with that, like, that's the big difference. That's one big thing that I want to talk about with MongoDB is it's a lot like JSON. So if you're using, say, Python or JavaScript already, the move to MongoDB, adding MongoDB, is pretty seamless. If you have Python and JavaScript dictionaries and objects, dictionaries and objects, it's really easy to add MongoDB because your format is already in your data is already in the format that that MongoDB expects. It's already in those dictionaries and objects, so it's easy to transition over to this. And yeah, this is a NoSQL database. So there are a lot of other databases. There are a lot of other structured databases other than SQL. There are a lot of NoSQL style databases. I believe NoSQL is a specific query language, but MongoDB is not SQL. And there are a lot of different approaches that have all different advantages and disadvantages. Yeah, but this is not a relational database. So I'm highlighting MySQL and MongoDB, but I'm really highlighting these as the difference between structured relational database and a non-structured, non-relational document-based database. And then if we want to pull information out, we get our collection and give it a JSON-style object to be able to look up whatever information we need. So here I'm going to get all the values in this collection with a username equaling Hartloff. Or if I want to do the equivalent of select star in SQL, I'm going to do find and then some empty dictionary, which is to say no query parameters. The username must equal Hartloff, and we could have a comma here and several different key value pairs to have multiple criteria that we're going to make sure that they're all matching. Or we say no criteria, just give me everything in this collection. We can do that too. So the big difference, MongoDB is very unstructured. You can throw things in this collection, and the structure never really matters with, I shouldn't say never really matters, but it's not going to check, MongoDB is not going to check any structure for us. If we have a collection, which is similar to a table, we get multiple collections in a database. If we have a collection and we give it an object, it's going to take that object and add that to the collection. It doesn't matter if I have 3 objects in a collection and they all have different key value pairs. If all the keys could even be different, everything can be completely different in between all of those documents. And MongoDB doesn't care. It's not going to enforce any structure at all. Where SQL is, that's what the S stands for. It's structured. It's very firm structure. When you create a table, you must define every column exactly. These are the values that I have. These are the types of those values, and those can't change. You can do database migrations, which will create a new table, with different columns, and move over all your data. But it just simulates a change. You can't actually change a SQL table, to my knowledge anyway. Maybe there's some advanced built into the server that can simulate that change too, but you can't change that. Everything must be predefined. So the big advantages here is, actually I want to highlight this. SQL is very fast. If you're worried about efficiency, if efficiency is important, SQL is the answer. Some SQL, or at least some structured database, is your answer. You wouldn't want to use MongoDB if efficiency is a big concern. So my hot take on this, MongoDB is the best if you're prototyping. You don't know what your structure is, and your structure might constantly be changing. Think of a hackathon. As you go through a hackathon, the structure of your database is going to change by the hour, if not the minute. Like, oh, wait, we need another field here because we forgot to add it in, and I guess we need that for our structure. And you can just change all of the structure of your database at the drop of a hat. You decide, hey, I want different attributes in all of my objects. No big deal. And then you just add it into your code. When I pull out information, if a specific document doesn't have that attribute, use whatever default attribute you want, whatever default value you want for that attribute. If it's old data that you created before you made that change. Very flexible, makes it easier to work with when you don't know what your app is going to look like yet. Once your app settles down and your structure of your data settles down, and you have clearly defined structure in the way your app is set up, then it's probably time to switch over to SQL and take advantage of all that efficiency that SQL gets you. SQL can index very efficiently. It can retrieve data very fast, very quickly. And you want to take advantage of that in a mature app once it's ready to go out there, ready to be deployed, used by users. But in development, MongoDB has a lot of advantages. But it's all give and take. And sometimes it just comes down to what you're comfortable with. If you've worked with SQL for a while already, just working in SQL would be fine.